Okay, so let's take a look at how this can help us solve problems that are not right angles. We were dealing with pretty limited numbers of real life problems. Not everything in real life is a right angle. It's just not going to work out that way. Things aren't going to be straight the way we want them to. And so we really need these laws to help us with trig for things that aren't straight. Okay, so let's go back to a tree problem like we had before. And a tree is going to grow on ground that isn't level. So it's growing on a hill, not on level ground. The ones we did before were always on level ground. A tower, whatever. Okay, but this is not level ground. It grows on a hill. This hill is, has a slant to it. And the elevation of this is 5 degrees, 45 minutes. Now that's DMS, which means your problem should be in DMS the whole time. You want to measure the tree. You want to figure out how high this tree is, but you aren't able to climb it. It's not safe for you to do so. So you stand on the same hill, and you stand 40 meters away. Okay, so your distance is 40 meters. And you're going to look at the top of the tree with an elevation angle yourself, all right? So you're craning your neck. Your eyesight is looking at the top of the tree. So the tree top. And your angle of elevation that you can see the tree at is 68 degrees, 50 minutes, and that's your elevation. And the question is, how tall is the tree? And it is possible for you to measure it at that point. All right, so let's see how this is not a right triangle situation. Okay, our tree is growing on a hill. Okay, here's our tree. Okay, maybe if you've ever been to the giant sequoias in California, seen some of those massively tall trees. Okay, so there's our tree. Before, we were measuring the tree on level ground. Okay, so imagine that there was level ground here. If it was level ground, it would have been a perfect 90-degree angle, but it's not. Okay, it's not level ground. We know now that the hill, I'm going to zoom way in, and I'm going to write it very small, that the hill is 5 degrees, 45 minutes. If it was level, it would be 90 degrees. It's not level. The hill is taking up 5 degrees, 45 minutes. But could you use your 90 degrees, what it used to be, to tell me how many degrees are actually above that hill? We know the angle is 45. How would you figure out how much would go there instead of 90 degrees? Just subtract, right? You just start over and you subtract. Okay, if it was flat, it would be a 90-degree right angle. It's not 90 degrees, it's less than 90 degrees. In fact, it turns out to be 84:15. Together, that's 90 degrees total, but the hill was cutting off 5 degrees, 45 minutes of it, so I only have 84 degrees left. Okay, now you are putting yourself 40 meters away over on the hill, and you're looking up at the treetop. And we know that that angle of elevation down in there was given to be 68:50. And we know that we were positioned 40 meters away from the tree on the hill. Okay, this forms a triangle that's not a right triangle anymore. Okay, this triangle doesn't have any 90-degree values. But I feel like the best way to set that up is to assign some letters to the different positions. So let's assign letter A to the corner where the tree hits the hill. Let's assign letter B to the top of the tree. And let's assign letter C where we are standing. Okay, and so then for setup, you'll do your traditional setup of A, B, C compared to A, B, and C. Okay, I got to fill in at least 3 of these spots. Okay, Angie, you want to pick one? Pick something and fill it in for me. I got to fill in 3. Specify which A you mean. Okay, capital A is 84:15. Okay, 84 degrees, 15 minutes. Good. Okay, Sarah, pick something else.
Big C is 68 degrees, 15 minutes.
84:15. Big C, she says 68:50. Okay. All right, well that really leaves, I need one more number filled in. Devin? Okay, perfect. Can I figure out big B? I certainly can. Since I've got 2 out of the 3 angles, I can use the rule of 180 to do a little subtraction. So I can take 180, I can subtract 84 degrees 15 minutes in DMS in my calculator. I can also subtract 68 degrees 50 minutes in my calculator, and in DMS, that will give me the value for B. So please make sure that if your problem is DMS, that you list your answer as DMS. And that turns out to be 26:55. Okay, yeah, Lena. Very good. Okay, the small b is 40. So we've got to put 40 on one of the legs. It is directly across from capital B, and so small b is 40. That's the ticket right there. Once you get a pair, you've got to have a pair of values in order to set up the law of sines. And so now that we have this pair, then we will set up the law of sines. So sine of the 26 degrees and the 55 minutes goes on top, and the 40 goes on the bottom. Now I have to make a decision about which of the other pairs or the other values to use, if I should use A or C. Now my question is, how tall is the tree? So which of the legs would answer, yeah, how did you know it was C? Yeah, okay, it's across from where the person is standing, and so C is going to be the value of the tree. And so then I'm going to use sine of 68 degrees 50 minutes on the top, and then C on the bottom. So that's the setup. So you don't have to, if the picture's in the book, you don't have to draw the picture. But you should have the capital ABC and the lowercase ABC sort of set up in rows that you can match those up, and some cross multiplication. All right, so I'll cross multiply. C will cross multiply across, and I'll get C times the sine of 26 degrees 55 minutes. And 40 will multiply across to 68:50. And then we'll use one big division problem to get rid of the sine and the 26:55. So I'll have 40 sine 68:50 over sine 26:55. And just a reminder, the word sine doesn't cancel each other out. Okay, has anybody previewed that already? I've got a value, but I want to make sure I've typed it in correctly. Carter? Yeah, okay, I wrote down 82.399 meters. Okay, so the height of the tree, if you're converting that to feet, that's over 250 feet tall. Okay, any questions on that one? Yeah. direct distance. Okay, so yeah, so then you would find side A. You mean like, pause this a sec. Okay, let's do then one boat question. All right, in fact, two boats. Two boats leave the same harbor at the same time. But they're going in different directions. And the directions are and one direction is 137 degrees bearing, and the other is 221. After 4 hours, we can measure the distance between them, and they are 258 miles apart from each other. The first boat had a speed of 37 knots. Remember, a knot is a nautical mile per hour measured on water. And so our question is, what is the speed of the other boat? So what is the speed of the second boat? Okay, so we want to be able to, yes, get a visual on this, so we can picture that this is not a right triangle, but then hopefully still solve. All right, I put a dot on there that measures the harbor, and now we need two boats leaving that same harbor at the same time but going in different directions. One is going 137 degree bearing. So what compass direction is that-ish? Southeast. Okay, so we've got a boat heading out that way at a bearing of 137. The other boat is heading off in a 221 bearing. So in compass terms-ish, what is that going? Okay, approximately southwest, so 221, maybe like that. Okay, with a bearing of, this time, 221. That's the, okay. My question to you, how many degrees are between the boats? Okay, because that is important, because neither 137 or 221 are actually in the triangle. The amounts that are in the triangle are the angles between the two boats. Which would you say is how much? Subtract them, yeah, it's not, how much? 84, yeah. So 84 degrees are the amount of degrees that are actually between the boats. And that is an important number to know. All right, we also know that now between the boats, the distance, we know the angle between them is 87 degrees. The distance between them was given to be 258 miles. So 258 miles is directly across from the 84 degrees. So let's call them boat A and boat B. Okay, the other tidbit of information we have is the time that this has been elapsed and the speed of the first boat. Okay, so Devin? Yeah, 37 times 4 is going to go where? What is, well, first of all, let's figure out what 37 times 4 is. Okay, how much? Okay, and where does the 148 go? The first boat, which is 140, what did you say? 8? Okay. All right. So now we're ready to set, we've got 3 pieces of the triangle. It only takes 3. We've got 84 degrees. Yes, okay, so it says the first boat, which was the boat that was going 137 degrees. So you do it in order. The first boat would be the one that was going at the first bearing. A lot of times they'll say the word respectively. That means when you're reading it, you're keeping the order the same. If it says it first, then the first one would match up to that. Okay, all right, so then let's set up A, B, and maybe H this time for the harbor. And then we'll have A, B, and H. The only angle we've got is 84 degrees, which is the degree separation between the boats when they left the harbor. Where do I put the 258? Okay, 258 is H because it's directly across from the harbor. Where do I put the 148? For A. And that is enough. All right, now I need to start working on, I've got a pair of values, so I want to set it up and start working on cross multiplying. Trevor, just for practice, you want to try setting it up?
Not really.
Okay, all right, so somebody else wants to try? Maybe Aviana? Oh, Hayden volunteered. Okay, you're off the hook. Okay, go for it, Hayden. Okay, so the pair, 84 and 258, match together. So we want sine of 84 and over the value of 258. Okay, now that's the full proportion that you could set up. Now you can set up a half proportion. Okay, I need you to be careful about that. You can't just put an A there. It has to be sine A, yeah. The numerators both always have to have a sign in them, and so if you're neglecting that, then that maybe would have explained why all those answers didn't come out right. Okay, so that is set up correctly. Okay, all right, so now we're ready to cross multiply. So I'll do my 258. So 258 will go across to sine A, and 148 will go across to sine 84. Now we do want to get capital A alone. And so in order to get capital A alone, we'll divide. So I'll have 148 sine 84 divided by 258. Okay. And so that gets rid of the 258, but it doesn't get rid of the sign. So I also need to do sine inverse. Now A will be alone, and I will have sine inverse. I'll be able to find the value of A. Okay, has anybody worked ahead and got that value for A? Yeah. Does anybody confirm that?
Yeah.
Okay, great. All right, so then we'll go back up, and we've got, all right, 34.785. All right, 1 down, 2 to go in terms of the pieces we're trying to find. Once we've got capital A as our angle value, and we already have capital H as our angle value, we should be able to find capital B. Alina, had you worked on that ahead of time already? Okay, so somebody can use 180 to do a quick subtraction. Scott, what did you get? We're doing angle B.
Okay, angle B, I got 61.258.
Confirm?
Yes.
Okay. All right. Last step. Okay, Trevor, how about this one? Now that you saw it once.
Yeah. So.
Okay. So here I'm gonna do my work over on this side. Okay.
So the be sine 34.785.
Okay, over.
148.
Okay, that would be one way to do it. You will be just a smidge inaccurate if you use, I always recommend using the same one both times. So if
Okay.
you use sine 84, 258 the first time, use it again.
Okay.
Because the 34,785 that we came up with was actually a rounded number. So if you use a rounded number and then you use it again, you'll round it a second time and then you're going to be less accurate. So I would go back to the exact ones if I were you. So I would start with the 84. So I'd start with sine 84 instead. It'll just be a little more accurate. Over.
258.
Okay. And then the other one? Because what we're trying
This is, I think, the part that I get stuck on. I
Okay.
have like no idea what other value to put in. It's like, it's sine B, right?
Okay, well we know what B is. So sine of
61 point. That one we can do like that?
sure. Yeah.
Okay. And then over just B?
Over just B. That's the one I don't know. Yeah, you're allowed one variable. That would be the one variable. Okay, so then we're going to cross multiply that one. And you'll have B cross multiplied to sine 84 degrees. And 258 cross multiplied to sine 61, 215. All right, we want to get B alone, so we divide. So 258 sine 61, 215 degrees over the sine of 84 degrees. So make sure you do type the sine button twice. One for the numerator, one for the denominator. It's not like the signs cancel out. Okay, you get one of each. Sarah, did you get that? Oh, you don't have your calculator out.
I can.
Oh, that's okay. We don't want to wait for it. Jared, do you have it?
I got 227.36.
227 point. Okay, and what are the units on that? Okay, these are miles. All right, so our boat went to, say it again, 227.315? 365. Does that answer the question? What's the question? What's the speed? Okay, so it went that far in how long? 4 hours. So how do you figure out the speed? Divide it by 4. Okay, so let's take that number, divide by 4. So the speed of boat B should be 50, what? 56 point, does it work out evenly to 84? Okay, and then what are the units on that? Miles per hour. Oh, no, knots because we're on water. Okay, so just because we got the side of B didn't mean we technically answered the question. We still had to go back and figure out the speed using the time.